Hi folk, my name is Mike Grant and I'm here to chat to you a little bit today about Chat GPT in the various forms, so GPT 3.5, GPT 4, as well as the Bard offering, some other stuff from Microsoft. I'm just sort of going to unpack exactly what it is that this technology can do and some of the challenges around using it in your firm. Just as a bit of a start, I thought I would take a moment to share the very classic Chat GPT interface. This is provided by OpenAI. And there are a couple of really interesting components to it, maybe some really subtle things too. So the first is that there is a chat window wherein your Chat GPT responses are also returned, and you interact with the service by typing in any free-form text in this box at the bottom. We're going to talk to this a bit later, but it's a perfect matching between the sophistication of the question you can ask the service and the way in which the answer is returned. What's more natural than having a conversation? There's some set of history where the conversations you've had previously are covered, and then of course there's a way to make money for OpenAI and license the service. Specifically in the talk today, I'm going to speak a little bit about where I came from, where the origin of this specific technology comes from, why we've seen this incredible rate of adoption, why it is so good, this unreasonable goodness that we speak of. I'm going to speak a little bit about some of the legal wrangling that's happening at the moment. There are a few landmark cases that are actually being argued at the moment. They're going to set precedent for how we think about these services into the future. I'm going to talk a lot about plagiarism, how it is that we can detect it, but how it is that we can't actually effectively protect against it. I'm going to talk a little bit about the system limits, about a playbook for your business, where I detail 4 strategies, and then I'm going to provide this very specific call to action. So diving in further about ChatGPT and its specific range of things that it can deal with, I asked it a question. I was involved with a bit of a transaction, and there was an item listed in the financial statements of this business. And when I asked the folk around why this existed, the answer I was given was, well, I'm following the IFRS 13 standard. Now, I know nothing about accounting, so I went and asked the ChatGPT exactly what is IFRS 13, and it returned some result here. And I posed a follow-on question to it, which was, well, why is this specific item included? And it gave a really good answer. And this was good enough to go back to the firm that I was engaging with to ask some follow-on questions and determine exactly what it is that it meant. I've asked it some pretty complex programming questions. So this is a very nuanced and niched question with Rust, which is a beautiful programming language. And it talks to some very specific knowledge around what's called a B-tree map, or a way in which we can traverse a set of items in memory. And it's really interesting because if I go and search for this specific text, I won't find it anywhere. So if I go plug this into Google and I go and search the corpus of the world's knowledge that have been indexed by Google, I cannot find this exact collection of words. So it has been generated out of the knowledge embodied in this model. Right, I can go and ask a follow-on question around how I can iterate over it, and I get a very specific implementation that is correct and will run as well as an intended output. So this is a really good result that we're able to get out of the system. Very useful when it comes to programming and as an assistant to help you solve a specific technical challenge. It can make really good mistakes though, and it can lie to you with absolute conviction. And so one of these beautiful examples put together by a colleague of mine was the simple question, how many letters does this sentence have, right? The first time the system replies, it's like, I'm not even going to try answer this question. I can't do it. I ask exactly the same question, but in a slightly different way, right? The language has changed, but the core question, the core task the system has to solve for has remained the same, and it tells me there are 39. There are exactly 48 question out here. But then we can use a different kind of prompt, which is called a chain of thought thinking. So you can actually provide the process that the AI system needs to follow in order to obtain an answer, which was here, list out each character and count them out, in which case it's quite happy to oblige. It lists it out and it counts out to 47, which is also not the correct answer. You can ask it now because it can write program and write code. So it says, well, write the Python code to go and solve for this. And it generates a valid and correct output. But when I ask it to evaluate the answer of that code, as it did with the previous Rust example, that was correct, it comes up with 57. So there isn't a Python interpreter embodied inside this. It is emulating it, and we refer to this specific type of error as a hallucination, but it's very clearly a type 1 error, so it's an error of commission, 57, and remember there are 48 characters in the sentence. So it's quite a powerful tool with some respects, but it's got this very strong tendency to generate an answer with conviction that may not necessarily be correct. And so you need to be aware of that when you use the service. And it's gotten so bad that these folk here, which is called OpenCage, had this thing, right, where it says, hey, Chat GPT is really cool, and they've used it. And then the code that the Chat GPT service was generating and returning to users spoke about using the OpenCage API. And so they actually had to create this web page to say, no, we don't actually offer this phone lookup service, because when you pose to OpenAI a reverse phone number lookup, it generates an answer that points at OpenCage, which is quite a challenge, right? So this is one of those type 1 errors again. That's actually led to a company having to be very specific about saying, we don't actually do this. We never have, we never will. To talk a little bit about the progress we've had to make in the field to get to the point where we have models that are this powerful. It's really important to select a couple of things out of the history of our evolution, right? And I think that in 1943, we came up with this individual model of a neuron. It was the math that described if you take a bunch of inputs and you sum them together in a weighted fashion and you apply an activation function, you get a result. And that's just one. We're talking about tens of billions of weights in one of the latest GPT models. So this is just one of those. We was contemplating this presence of these artificial general intelligences, or AGIs. And so a guy called Alan Turing proposed this Turing test and says, well, you achieve AGI at the point where you are no longer able to distinguish man from machine. We passed that quite some time back, right? But in 1965, we came up with a more complex version of these neurons. So we went from single perceptrons to sort of multi-layer neural networks. The math was really complicated, but we came up with a cute way of simplifying it. And so we could compute slightly deeper networks that could do more things. But they didn't really deliver. And so in about the early 70s, we entered what's called the first AI winter. And this is where the reality of neural networks finally caught up with the hype that had been generated around them. So the world became a bit disillusioned and stopped using it. In '82, recurrent neural networks were invented. These were fascinating things because they imbued these models with a kind of memory, a sort of way of preserving their internal state between one forward pass and the next. And so suddenly they could react to things as a consequence of prior actions. But it became very tricky to solve the math, and we ended up with this vanishing gradient problem. Finally solved that in 1991, where we came up with a way of modulating a thing called learning rates. We could get to a robustly trained recurrent neural network. In 2002, this open source package called Torch was released, and this suddenly brought neural networks to everyone's desktop computer. So researchers around the world could suddenly go and build their own neural networks. We found this explosion of different types of neural networks coming out of the early research. And we hit very quickly the computational limit again, solving the math behind these networks. And in 2009, we were able to get these neural networks to run on GPUs. And they were just perfect because it was vectorized math, and it was the same thing for displaying graphics from 3D games. It looked really a lot similar to solving the math that sits inside a neural network. And so we were able to suddenly take this huge leap forward in terms of computing it. So that in 2012, we had this ImageNet classifier, and this could look at a picture and tell you what was inside this picture. We could say, right, we see a cat, we see a dog, we see a cart, we see a horse. In 2016, we very thoroughly and convincingly solved AlphaGo, and so we were able to beat the best players. Recently though, just a bit of a segue, using a modified strategy, humans were able to beat AlphaGo in return, but it's a very niche kind of solution, and very quickly the system has now countered and prevented or is aware to that new strategy. And then in 2020, GPT-3 was released, and this was phenomenally powerful, but a lot of effort had to be put into prompt engineering. You had to use some pre-trained models or some further trained models to get some really good responses from it. And then in August 2022, the first Chat GPT model was released. And this didn't take too much of the world by storm, but then it just suddenly exploded. And I'm going to unpack that in a little bit now. Also, just a little bit of a discussion about the type of model that GPT models are. We have supervised models, which are really just a mapping between some kind of input data to some kind of result. You can use semi-supervised models, where you have a way in which you can use an unsupervised model and then provide a labeled result back that you could use for further training. You have unsupervised models where you have a look at data and you're looking for patterns that may be present, but you're not actually aware of what the patterns are. And then you have reinforcement learning, which is sort of like a domain exploration that you would use to discover an unknown domain or discover a new region within an unknown domain. And GPT is a combination of semi-supervised and reinforcement learning. So they call it RLHF, or reinforcement learning with human feedback. And it's a way just for humans to provide a ranking on the results and then to use reinforcement learning to go and explore this policy further. And it has provided a huge step forward in terms of the amount of training or the number of epochs you can run through off a specific set of data.